Okay, hello everyone. I welcomes to all once again in this lecture series on some special integrals, and we are discussing gamma function. In the last class we have been discussed definition of a gamma function, that is your 0 to infinity x to the power n minus 1 e to the power minus x dx, and these are the other forms we have been discussed and we proved also. Up to 3 we have been proved. Okay. Okay, and in this class we are going to prove this Weierstrass form of gamma function, that is your 1 by gamma n equal to n into e to the power n mu. This is your product, infinite product summation k equal to 1 to infinity of 1 plus n by k into e to the power minus n by k. Okay, and here mu is nothing but called as your Euler's constant, and its value is your 0.5772, and this also can be represented by this uh, infinite limit, that is your limit k tends to infinite 1 plus 1 by 2 plus 1 by 3 plus so on 1 by k minus ln k. Okay, and this Weierstrass form of gamma function, that means this much can be proved by using Euler's form of gamma function, that is your gamma n is another infinite limit, that is your limit 1 k tends to infinite 1 into 2 into 3 up to k by n into n plus 1 into n plus 2 up to n plus k. Actually, from this uh, Euler's form of gamma function, we have to start to prove this one. Okay, so let us start to prove this one. Okay, now we are going to start to prove this one. It is known that it is known that Euler's form of gamma function, Euler's form of gamma function is represented as gamma n, which is equal to limit k tends to infinite. What I written, I just erased that one, and again I'm writing correctly. Okay, clearly 1 into 2 into 3 up to k whole divided by n into n plus 1 into n plus 2 up to n plus k, and here whole into k to the power n. This is k. Okay. Okay, this is the Euler's form of gamma function. That implies, if I'm going to consider 1 by gamma n, that implies 1 by gamma n will be written as, just it will be reverse this one. Okay, numerator will be denominator and denominator will be the numerator. K tends to infinite n into n plus 1 into n plus 2 up to n plus k, n plus k whole divided by 1 into 2 into 3 up to k into, this will be k to the power minus n, k to the power minus n. Okay. Okay, now this one also can be written as, that implies 1 by gamma n also can be written in this format. Here you can see limit k tends to infinite n into n plus 1 by 1, here n plus 2 by 2, n plus 2 by 2 into n plus 3 by 3 up to n plus k by k whole into k to the power minus n, right? Then that implies 1 by gamma n Again I am going to modify somewhat. Here you can see n, this n plus 1 by n can be written as 1 plus 1 plus n by 1 into here n plus 2 by 2, that here 2 I divided with n and 2, it will be 1 plus n by 2, right, into 1 plus n by 3, then up to 1 plus n by k whole into k to the power minus n. Then that implies 1 by gamma n can be written as, here you can see carefully, limit k tends to infinite n into 1 plus n by 1 into 1 plus n by 2 into 1 plus n by 3, whatever written I written as such, uh, up to 1 plus n by k, यहाँ तक लिख लो. Here k to the power minus n can be written as like this, that e to the power minus n ln k. Okay, here you can see e to the power minus ln k is nothing but k to the power minus 1. How it is? Here you can see e to the power minus n ln k is nothing but e to the power minus ln k to the power n, or we can write e to the power ln k to the power minus n. So here exponent to the power log of k to the power minus n is nothing but your k to the power minus n, right? This is nothing but your k to the power minus n. So instead of k to the power minus n, we can write this one, e to the power minus n ln k. Okay, then that implies 1 by gamma n will be equal to limit k tends to infinite, whole into, here you can see n into 1 plus n by 1, 1 plus n by 2, 1 plus n by 3, up to 1 plus n by k I written as such. Then e to the power, then e to the power minus n ln k, ये तो है, इसको मैंने लिख दिया, here I written as such, into here I multiplied one infinite limit and I'm going to divide another infinite, same infinite limit, what, into limit k tends to infinite, exponent to the power 1 plus 1 by 2 plus 1 by 3 plus up to 1 by 1 by k, 1 by k into n. This infinite limit I have been multiplied, so obviously I will be I have to divide with this term, the same infinite limit, that is your limit k tends to infinite, exponent of 1 plus 1 by 2 plus 1 by 3 plus up to 1 by k into n. Okay, up to this it has been completed. Then that implies 1 by gamma n will be equal to limit k tends to infinite. Okay, here you just write whatever written, 1 plus n by 1 into 1 plus n by 2 into 1 plus n by 3 up to 1 plus n by k whole divided by exponent to the power 1 plus 1 by 2 plus 1 by 3 plus up to 1 by k into n. Because here you can see, here limit k tends to infinite, here also k tends to infinite, no need to write two times. So here I written limit k tends to infinite, these two terms I written as such, right? Here you can see, here exponent to the minus n ln k, here exponent to the power 1 term, here k is also there. So this term should be in this limit. So if I will put this term in this limit, then what I'm going to write? I have to write limit k tends to infinite exponent to the power 1 plus 1 by 2 plus 1 by 3 plus so on 1 by k, 1 by k. Here you can see 1 by k whole into n plus here or minus n ln k, right? Okay, so that implies this will be 1 by gamma n is equal to limit k tends to infinite this much n into 1 plus n by 1 into 1 plus n by 2 into 1 plus n by 3 into 1 plus n by 3 up to 1 plus n by k whole divided by, see here I written 2 times this step, you can omit, okay, in your exam, up to 1 by k into n. Here you can see limit k tends to infinite, here exponent to the power this much n minus, so here n I can take common. If I will take n common, then this will be written as exponent to the power n whole into 1 plus 1 by 2 plus 1 by 3 plus up to 1 by k minus ln k, minus ln k. Okay, okay. So here you can see limit k tends to infinity. This infinite limit or infinite series you can say is nothing but mu. Here you can see mu is nothing but 1 plus 1 by 2 plus 1 by 3 up to 1 by k minus ln k is nothing but your mu, that is your Euler's constant. So instead of this I can substitute the value is your mu, right? So limit this much is nothing but mu, I can substitute this one in our next step. So that implies 1 by gamma n will be equal to 1 by gamma n, 1 by gamma n will be equal to limit k tends to infinite, you just write what it is written as such, n by 2 1 plus n by 3. In your exam you have to omit the steps, okay, okay. Here I written detail, you just omit your steps. E to the power 1 plus 1 by 2 1 by 3 up to 1 by k into n, and as I told that this much is nothing but your mu, and that Euler's constant. So here it will be written as e to the power n and to mu, or you can write as limit k tends to infinite, k tends to infinite 1 plus 1 by 2 plus 1 by 3 up to 1 by k minus ln k is nothing but mu. You can write, no need to write this one because already at the starting I have been written the Euler's constant mu equal to this much. So what we found now, that implies 1 by gamma n will be equal to n e to the power n mu into limit k tends to infinite whole into, here we can write 1 by 1 term, that like this 1 plus n by 1 divided by e to the power n, e to the power n whole into this term 1 plus n by 2 whole divided by e to the power n by 2. See here, here this is the e to the power, if I'm going to write this one, this can be written as here e to the n, e to the n into e to the power n by 2 into e to the power n by 3 up to e to the power n by k, we can write. Yes or no? Same thing. These values I am writing in this format. Likewise, this one plus n by 3 divided by e to the power n by 3. Okay, up to 1 plus n by k divided by e to the power n by k, right? Okay, okay. Now that implies 1 by gamma n can be written as n e to the power n mu limit k tends to infinite. Here 1 plus n by 1 into, here you can see e to the power n in the denominator. If I am going to write in the numerator, it will be written as e to the power minus n. Okay, likewise here e to the n by 2 will be moved to numerator, means it will be e to the minus n by 2. So 1 plus n by 2 into e to the minus n by 2, right? Then third term will be 1 plus n by 3 into e to the power minus n by 3. Okay, up to 1 plus n by k into e to the minus n by k. So these are the infinite product terms. As k tends to infinite, so these terms moved up to infinite numbers. So and each and every terms here you can see are multiplied with each other. So if we are going to write in symbolic manner, then how we are going to write? Here you can see it can be written as n e to the power n e to the n mu product, here you can see product summation, or you can see infinite product k equal to 1 to infinite 1 plus n by k whole into e to the power minus n by k. So here we have been proved, I think. Here you can see n e to the power n mu, n e to the power n mu, infinite product symbol, k varies from 1 to infinite, 1 plus n by k, here you can see 1 plus n by k into e to the power minus n by k, e to the power minus n by k. So this one proved. Okay, okay. So similarly, simply if I'm going to write, if I'm going to write gamma n, then this will be 1 by n e to the power plus n mu, obviously it will be minus n mu, and the product, infinite product will be written as such k equal to 1 to infinite. This will be written as 1 plus n by k, n by k to the power minus 1 into e to the power n by k. Okay, okay. So this is the another representation of gamma function, or called as your 𝑽∗ form of gamma function. This is called as your WEIES 𝑽∗, 𝑽∗ form or 𝑽∗ formula of gamma function. Oftenly you can found this proof in your exam for 6 mark, 4 mark, 6 mark, like that. So just practice it and try to remember this one, which will be useful for our forthcoming videos. Okay, so for this class, up to this much. Okay, go through this video and try to practice and remember for your exam. Don't, you should not bother about the note, because I will upload the note in the PDF format. You just download that PDF and watch this video, direct prepare for your exam. Thank you so much for watching this video. Next class, in the next class, we are going to discuss properties of gamma function. Okay, thank you once again for watching this video. Thank you.